Alright, welcome to my stream. Completely forgot to do my little VTuber stuff. My totally not a webcam. Although it actually isn't, but... Okay, so what is on the docket today? Since the last stream, I've done quite a bit of research, and I've looked into like how other people have done energy component systems, and just kind of figuring out what kinds of things that yeah, so I found a couple tutorials that were actually really good, and one of them pretty much almost perfectly matches the kind of thing that that I've been trying to go for. So I'm going to effectively just do that entirely. So I'm gonna get rid of all of these, and I'm going to do things a little bit strange. Just because I don't even know what's going on with my VTuber stuff. It's like not working. I'll just close out of that and try and relaunch it, perhaps. It's struggling. Oh, now it launches. Bloody hell. Okay. Cool. Anywho. Yeah. So. There are going to be a number of interesting things I'm going to be doing with it too. Just with how things go. There we go. There we go. There we go. That's working. Okay. So... Alright. Let's get into here, and there's a few things that are quite a bit different. So using entity, I mean, I could do type def. Yeah, I'm gonna do type def. Oh well, actually using the syntax is a little bit easier. So I'm gonna do using entity equals size t. There's that, because an entity is just an ID. And then I'm going to do define. No, actually it'd be better if I do hash define. I think would this work? Oh, I don't think my mouth is working properly though. Let's fix that real quick. Doobie 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 doo. Doobie doobie doo. Oh, microphone. Oh, okay. Now it's working. Cool. So I could do a const. I think I'd prefer to do let's do 1024. 2048. Well, how many? 2048, 4096, 4096. Yeah, I think that would be good. Hopefully. Yeah, no viewers yet. That's okay. That's kind of hard to read. I'll do that. Nah, I'll do this. Just to break things up a little bit visually. Okay. Region in region. Do that a little bit. Do that a little bit. Nah. Wow, my PC is struggling. Come on. I could really use a new laptop or something. I don't know. So, that's it. So, in essence, the entity is just an ID, right? And we want to have some kind of max entities. This is the maximum number that we're going to do, right? I mean, I could just do one bit shift left, you know, one bit shift left by, 16. You know, that works. I'm okay with that. I'm just gonna do that, and just to really nail it in. Okay, and now the next thing is we should have some kind of component. Let's do a struct component, struct C text, and then we can do a cd string text. Okay, so that's just a good testing kind of thing, right? Now I think later on, for certain things, we would want to have the system managing a lot of stuff. Well, yeah, I could probably delete that then. That's fine, because that's not going to be a thing anymore. So I can do using component type. Type to 1. Yeah, I'll do a hash define. Well, I mean, I guess. Well, I guess I could do another using. Oh yeah, I guess this is a define. Wait, what? Yeah, okay. So we do a using component type. So that was T, and then hash define X components, and then I'll do, actually, that's how you actually do define. You don't want to do the equals. The equals doesn't work. So define max components, wait, right, hash define, let's double check the documentation, shall we? So, C++ hash define. Define directive. This is a pre-compiler. This is a pre-processor thing. Okay. So max components, let's do 1 bit shift left, 8. Right, yeah. I mean, there's like other ways of doing this. Like, this is a little bit not good for memory, because this would be better to do 65,535. Right, and then this one would be better at 255, just because of memory and stuff like that. But what I could do is this -1. So I can do this -1, right? This just means that in memory it will be stored more efficiently. Because this is the maximum 2-byte integer that you can get, and this is the maximum 1-byte integer. And then I can even go with like an unsigned what, but anyway, it doesn't really matter. I think the compiler can kind of figure stuff out anyway. So we have the defines. Let's go back to this. And then we want to have a signature. The signature could be, what is the signature? The signature is going to be a part of the entity stuff. Right? So in here we want to have a signature. And this is going to be an FTD bit set of size. Bit set? I'm going to do include. There we go. Max components is undefined. So well, I mean, guess I could just make signature be a component thing. Because it is a component signature. It is the fingerprint that dictates which components a certain entity has. So, what? I guess we could define the entity manager. I guess we can define the entity manager outside. And we do want to have a bit of a hierarchical, a little bit of some stuff. Right, yeah. We have the component manager. Yeah, and then that has some stuff to dictate what's going on. Okay. Alt tab. So we want to have, what do we want? We want to have the entity manager. Right, so let's define that up here. Class entity manager. Save. We'll have public. So what things do we want to have? Well, we want to have the constructor, right? Alright. We want to have create entity. And that's done. We want to have forward destroy entity. And I do believe that this takes in an entity. TDE. We want to have set signature. And then that will be an entity E and a signature S. Okay. And we also want to have a get signature, right? Signature get signature. And we want to take in an entity E. That's going to be it for those, and we also want to have a few private things. Okay, array of signatures where the index corresponds to the entity ID. Okay. Let's do private. And do std. God, such a weird one. Available entities. Let's go here. We want to have an array. Interesting. And then it'll be... No, not signed it. Signature. And then this is maxents. Maxents. And this is signatures. Incomplete typing is not allowed. I don't understand that. Ew. Error type. No, that is not too few arguments. Okay. This should work, but I don't understand why it's not. Okay, C++, FTT, right. Strange. Wait, where's... Oh, entity manager needs to be below signature. Signature needs to be below max components. Because it's not actually declared yet. That's what's going on. Complete type. Yeah, I don't understand why it's not working. Signature. Okay. C++. Not allowed. Before declared classes cannot treat an array with an unknown size when it can at runtime with a pointer to a pointer. Okay. Let's take a look. Okay. Okay, that's not really working. It's not the thing. Okay. So I'm not getting anywhere with this. It is not happy with me. I don't understand why. Alright, let's say int 64. Incomplete type not allowed. Oh, it's still not working. Okay. Let's go into 6+ FTD array. Take a look at what I'm doing wrong. Include array. Oh, it would help if I do hash include array. It's probably something that would be good. Yeah, and that fixes everything. Okay. I'm just a dumbass. That's what's going on. Okay. I love you too. Oh, actually, then I can probably get that and drop that back down to here. Okay, so it is still working properly. Because it is being declared at some point. Am I even going to be able to do this in 2 hours? That's the real question. Let's get rid of this, get rid of that, get rid of that. Okay, cool. We have that, and then we have living entities. We want to make sure that the private, and then this is size T. This will be a size T. Living entities, we'll do that. Living entity count. We used to keep limits on how many exist. That's a little strange. I don't understand why that's a thing. I'm not going to do that there because the tutorial doesn't. And I don't really understand why that's a thing. It shouldn't matter. I understand queue and array having an empty thingamajig, but it's not even a... whatever. It's fine. So, now to do just a little bit of explanation. Let's go all the way down to the bottom. Alright. Let's say, right? So let's say we have. So what exactly is happening, right? What we want is we have right. What is effectively happening? Right, so we have what we want to have is like, what's going on here? Entity manager, there's all this stuff going, right? So okay. Okay, so we want to have to an array index mapped from array index to entity ID. Okay, so what's going on, right? So we want to have the components array, right? We have that there. And we have entity to components, right? We have that there. And then we have a component to entity, right? And we have that there. So effectively we have 3 different arrays. One is the actual data, right? We have the actual data array. Then we have one that maps entities to components, and then we have one that maps components to entities. Okay. So what we want to do is say, right? So what happens is we add things, right? We can have, you know, A, and then here we have 0 maps to 0, and here we also have 0 maps to 0. Okay, that's cool. Then we add B, right? And then here we have, you know, a new thing where we have a 1 maps to 1, right? Here we have 1 maps to 1, right? That's cool. That's all fine. That's fine and dandy. Well, you know, I kind of like this, right? So we have a list here, right? And we have a C, right? We have C. What happens there? Well, we add 2 maps to 2, right? And then in the component array, we say 2 maps to 2, alright? So everything's working fine, right? Everything's all Gucci Poochie, right? So then, just for completionist's sake, let's do, you know, a D, right? Which is 3 maps to 3. And 3 maps to 3. Cool. Alright, that's fine. Now what happens if we want to remove B, right? Well, if we remove B, then we have a hole. And holes are not good in arrays. In fact, you can't have holes, because then you have to do validation and all this stuff. So, what is a better way of removing it, right? Now, one thing that we can do is we can just say, hey, D, move into that spot, right? Just move D into B, right? Which means that what we want to do is then say, hey, instead of this here, well, we just in here, we remove the last one, and we change this to 3, and then here, we remove the last one, and change this to 3. Okay. That's effectively all that you need to do. Right. And then you can add, say, E. Then here we say, well, we say yeah, and then here alright, and then we say, hey, 4 is mapped to 3. And then here we say 3 is mapped to 4. Right? And then we can even do this again. We can remove, right? Copy this. We paste it here. Remove that. Right? At which point we delete that data and make this 4. We delete this data and make that 4. And it'll all work out. Okay. That's pretty much how it's going to go. And I allegedly have a viewer. So tell me what the worst programming language is, and why is it Python? So that's kind of how we're going to be doing that. So let's see here. So how do we actually implement this kind of stuff? Alright, so we know that we have to do that. So I'm going to do the header stuff first, and then I'm going to go into the CPP and get that worked out. So first what we want to do is we want to have an interface. So let's make an interface. I components array. Let's save, and then this one will have a in public. We'll have a virtual components array, and you'll understand why this needs to be a thing. Sinocron, an engine for a computer building company? No. StarForge used to be was an indie game made by a pair of Canadians, and they completely abandoned the project like 10 years ago? Damn, 10 years ago, yeah, they completely abandoned the project, so I'm writing a game engine from scratch in C++. Didn't really realize that StarForge was a... I'm gonna have to look that up. StarForge. I'm gonna have to do a little bit of stuff. StarForge. Let's see what comes up. StarForge systems, custom gaming PCs. Okay. When did they... Yeah, StarForge is a video game. Huh. There's all kinds of stuff all over here. StarForge systems. That's a little strange. Interesting. I learned something today. I'm probably going to change the title name, but I'm going based off of what the stuff. No, it's CPP 20. Oh, I need to make an I in front of it. Yeah, it's the newest C++. Because a lot of the documentation is going to be relevant to the newest C++ version. So it's a lot easier for me to find the kinds of documentation that I will need in order to finish this project if I'm using the current stuff. Yes, I do, but I'm also more familiar with hash define than I am with const expression. Because I'm actually relatively new to C++, I'm a lot more familiar with C#, but when building a game engine, C# loses power very quickly, and it becomes more and more difficult to do things that are very graphical, especially if you're using shaders, like using Vulkan, which is something that I'm going to want to use at some point. And there aren't any good Vulkan bindings for C# yet. I think OpenTK has it, but I think OpenTK is only OpenGL, and while yeah, at first I'm going to be using OpenGL, I just think it's just going to be a lot better if I use C++. So I'm just kind of working with what I know, and I don't know a whole lot of the super ultra modern C++ stuff. So I am using a lot of things that are all the way back from C, a lot of things from C, CPP 11, CPP 17. So I mean, yeah, raw Vulkan for solo development is an absolute nightmare. But, and I also don't really know a whole lot. Yeah, OpenGL will give me a lot of flexibility, which is why I'm using it first. It's also a much simpler API to work with. But if you want to take a look at raw flexibility, nothing is going to beat Vulkan, especially given the fact that a lot of the things that I'm going to want to be doing later on, because I am going to be rewriting this whole entity component system to use compute shaders at some point, or at least I'm going to try to use compute shaders. Using compute shaders is a little bit dicey, when it comes to things that are going to be needed to be updated every single frame. So I don't think every single kind of component will be able to be using a compute shader, but things like physics absolutely should. Potentially even AI should be using compute shaders, because these are things that are going to affect rendering, so all that data is going to need to be on the GPU anyway, so I won't need to have a lot of back and forth between GPU and CPU. So like the physics engine is all going to be run on the GPU, and that's one of the main reasons why I'm using an empty component system, so that I can just offload that data onto the GPU as one massive buffer and have the GPU run all the physics calculation in one shot for everything that needs to use physics, so that I can have far more active items in the game. So it's, and in order to do that, I can use OpenGL, compute shaders with OpenGL, but Vulkan's API is a lot better suited for doing crazy kooky stuff with your GPU. And OpenGL is not very well suited for that. At first it will be fine. I'm using C++, and I'm going to be, yes, I will be writing my own physics, because I'm a crazy person who hates himself. I'm basically going to be using the bare minimum number of external libraries. So I'm going to be writing my own vector classes, my own quaternions, all of that stuff I'm going to be doing myself. It's not because I think I can do a better job than using like the Havoc physics engine or anything like that. And it's not even really that I don't understand, it's not that I feel like I don't understand them so I shouldn't use them, I should write it myself. It's a lot of the direction that I want to go with this isn't that I can do better, it's that I want to teach people. My expected timeline, like for releasing StarForge, it's going to be a fat minute. I feel like getting the engine to a state where I can make any game is probably going to be several weeks, if not a couple months. Especially if I can't put in too terribly much time off stream. I am planning on increasing my stream time here very soon. I just need to work out what my schedule would have to be in order to facilitate that, with both home life and work life and all that stuff, balancing all that stuff. But I am planning on increasing my stream time quite a bit, and that will help shorten the timeline. So it will be a while before I even make small games with this engine. So making StarForge is going to be quite a bit. However, if I am intelligent with how I write the engine, then StarForge is just going to be content. Like by the time I even start working on StarForge proper, probably, but I also don't care. Like, yeah, it's probably going to be like 5 or 10 years or something like that, but I also don't care. Like, the original StarForge, 2 guys were able to get a functioning prototype in a very short period of time, and a large progress for this project is going to be, I'm going to be making other much smaller games first using the engine. So it's not just going to be StarForge. I'm going to be remaking Kern, which is a game that I made a couple years ago. I'm going to be making my own arena shooter in vein of like Quake 3 or Nexus and Zonotic. I'm going to be making my own Minecraft clone. So a lot of things are going to be, so this whole journey is going to be a lot about how do you find the solutions to the problems that you find, and also how do you find those problems, right? And I think that's something that there's not a lot of content like that out there on the internet. Like it exists, but it's also very, very, very short scoped, very, very small scoped. A lot of toy projects that go over a lot of these things. And I feel like having something that is much bigger, much larger scope in the long run would be nice to have. I am also, I need to actually do that at some point, but I'm also uploading all of these streams onto YouTube. Except for the very first one, I had some problems and I couldn't get to uploading it before it expired. I have seen Handmade Hero. I need to look into it a little bit more. So I would agree that's probably one of the only other projects that are in this same kind of vein. So it is very similar. Like, this journey is very similar to the journey of Handmade Hero. Alright, so let's get back to this. So let's do this virtual, yeah. I mean, and also, I really like, I really, really like just how games, like, exist. Like how games are made, how games work. A large inspiration for this project in general, in how I'm like making it and structuring it and stuff like that. Originally I was going to have the engine be an exe and the game itself be a DLL, but I quickly realized that that's not something that you can really do. Like, it's possible. So now it's just lib, a singular lib file with a singular header. I feel like that's going to be sufficient enough, because the way that I really wanted the DLL to work was that I really wanted it so that you wouldn't have to have a header file in order to develop a game using this engine originally. But in order to make that work, it was going to be an absolute colossal nightmare. And I feel like enough systems use static libraries with header files enough that it's not too out of the ordinary to see even a small, you know, an independent, like, this is an indie engine. You know, it's not an enterprise level engine, so I'm not going to have like a huge editor or anything like that. That's far outside the scope, so I'm not going to be building Hazel like the Cherno. But he's also, you know, and that's another thing, is that I do not suggest that anyone else do what it is that I'm doing unless it's something that they're actually passionate about, or that they want the experience or something like that. If you want to make a game, just use Unreal Engine or use ClickTeam Fusion for all I care. Like, it's fine. If you want to make a game, then don't make your own engine. And if you are going to make your own engine, use external libraries. Don't build everything yourself. Do as I say, not as I do, kind of thing. But I also want to show people how these systems come to being. So that's the main reason why I'm doing it. And again, I'm a crazy person who hates himself, so let's see. So I have the interface. So let's do, yeah, this thing needs to be a template, type, name, t, class, yeah, it'd be input language switching. I don't care. Stop. I don't care about input switch. Stop it. Yeah, it's a component array. Okay. Component array. Boy. Oh, come on, computer. Don't do this to me. You were doing so well. Can you stop it? Oh, it is updating it. Interesting. That's cool. That's good to know. And I would also say that if you want to make a game entirely from scratch, use C#. It's so much easier to work with than C++. I love C#. I adore it. It's so nice. Let's do the public first, and then I can do the private later. So I'm going to have to do a void insert data. And then this is going to be, yeah. Why does everyone want to love on Rust? Like, I don't care about Rust, to be honest. Like, I feel like Rust is overrated. And Java can suck it. I hate Java. I hate Java so much. I know that Rust has more security, it's safer code, yada yada yada, but I also don't like... I mean, C# just fixed everything that was wrong with Java. That's all that it is. Void remove data. Void remove data. Yeah, be entity. I mean, the thing that I like about C# is that it is great for 95% of your projects. Like personal projects, C# is perfect for it. And then for the final 5%, just use C++. Because C++ isn't going anywhere. You know, it's going to be around until the end of time. Just like CUDA is going to be around. Like, it's not going to stop. CUDA is not going anywhere. Get data. Entity. That's a little bit interesting. Okay. It's not going to. It's never gonna die. It's so ingrained in government systems and banking systems that it's never going away. It will never die. I mean, even BASIC is still kind of around. You know, I'm not saying that CUDA should stick around, I'm just saying that it's not gonna die. Entity destroyed. Why is that replaced with Vulkan? Oh, wait, no, not CUDA. What is it that I'm thinking of? CAB, programming language. Cabal. It's Cabal that I'm talking about. Cabal is the thing. Yeah, there we go. Yeah, Cabal is not going anywhere. I think. And what is the, what's the programming language I'm thinking of? Language for banking. And it's like Java, Python, Scala, Ruby. What is it that I'm thinking of? There's like a really old-ass programming language. I think it's Cabal. Yeah, it's based off of Haskell? Oh, good god, force dark mode, my eyeballs. I can't... I don't know. I'll have to... I'm getting a little bit sidetracked, but I think it's Cabal I am thinking of. I'll have to do some more research into it. Entity destroyed. Override. I don't understand why... Why does that have a Dubu jam? Oh, because it has to. Then I guess I can do that? I don't understand why that's a thing. Yeah, because I need to override entity destroyed. I mean, Kuda doesn't need to stick around. I would agree with you on that one. But I don't think NVIDIA is going to allow that to happen. But yeah, no, you can just replace Kuda with Vulkan. It's super easy. It's more available. Entity destroyed. Entity override. I don't understand. Oh, override. There's one more thing there. Not enough R's. Cool. And then privates. Alright. Oh, let's see. You seem to be someone who knows a lot about programming languages. What's your least favorite programming language? And why? Is it Python? Come on, Visual Studio. There we go. STD array. And then we want to have T. Right? Yeah, maximum entities. P components. Alright. Oh, well, I don't need that to be. You don't need that to be capitalized. Yelling at the O. Component. One unordered map for the entity to index, and then the index to entity. UTI map, and the ITE map. The unordered map of type entity and size T. No, okay. T and size T. And then this is the, what is it, the E to I. P E T I map. UTI map. The ordered map of size T and entity PITE. Yeah. And then size T and size. Total size of valid entries in the array. I don't understand why that's necessary yet. That's fine. Cool. So we also want a component manager. Yeah, because I think next stream... Because I don't know if I want to start Sunday, Thursday, Friday, Saturday, that's 3 days, and then Monday, Tuesday. Yeah, I guess Sunday would be the start of the next week. Then if I have to start getting ready at 1:30, 4 hours before that would be 9:30. I'd have to get up at 9 and start getting everything set up. Yeah, I could probably do that. Okay, component manager. Alright, because we want to have a component manager. And last things like that. So we want a component manager. I'm also not super pleased with how all this is structured, but I can fix it later, I feel like. A lot of this is just getting it working and then getting it working well later. I don't need to go absolutely bonkers. Public. Template type name. Void register component. Okay. Let's type name T. Yeah, I want a space there. Save void register. Yeah, I think this would be a lot nicer later on, because then I can have in the system, in the scene constructor, the parent scene constructor, I can do a bunch of stuff. Otherwise, I don't know. Let's see, const char, void register components. Right. That's going to be in there, so that's fine. Alt tab. Component type, get component type. Templates. Type name key. Type. Yeah, that's an empty thing, and then add component. Type name key and component, cool. I can do that. And void. Oh, actually, it's also another template. Another templated thing. Name T. And then it is void add components. And then entity E T components. And then let's want remove components. Templates. Right. Yeah. Yeah, it's a void. Void. Remove components. We want TE. Yeah, because that's being done in there. I mean, technically speaking, happening T. Hmm. Yeah, it's not necessary for that. I'm not entirely sure if I like the way that works. I might have to take a look at it at some point. Another time. Template. Type name T. This is a T reference. Gets. Yeah. T. And then void entity destroyed. Void entity destroyed. And this is also entity. Yeah. Okay. Const char pointer. This is a little bit strange. Let's take a look at the actual usage, shall we? Why is the unordered map a string pointer? That's manager, coordinator. Manager, register system, player, create entity, component manager, add component, transform player, render system, render system. Publishing that. All the globals are using an event system, but I opted to instead funnel them into a single class called coordinator. Alternative name suggesting welcome as mediator. This allows us to have a single instance of a coordinator as a global or whatever you want. You can use it to interface with all of the managers. It also makes the usage easier because you can replace this coordinator, create entity, coordinator, add component, and coordinator, register system. Okay, that's the thing. So meta-managing between them. Okay, so they have that stuff, which is fine, but where is the string pointer stuff going in? Yeah, I don't really understand why. That's a little strange. But who am I to argue? His code works and I haven't even finished mine yet, so... What's this system? Where am I at? I'm at the component manager. Okay, all the way at the bottom. So I need to do the private stuff. No, I also kind of don't like these. Maybe. I don't know how I feel about that. That seems a little bit hard to read. That's easy to read. That's real easy to read. Haha. Huzzah. It'll be harder to type, but whatever. Make people watching this on YouTube on their phones a lot easier to see what's going on. See the unordered map. Map from type string pointer to a component type. I don't get why that's a thing that needs to be done. I don't get it. Why? I'll do it anyway. Map of type const char pointer to component type. And I feel like we switch this to a map with enum question mark. Because I feel like I can do this with an enum char pointer. Alright. But I also feel like it's not that big of a deal. To a component array. Change this to a map with enum question mark. Because I think I can do that again there as well. STD unordered const char tab, and this is a standard shared pointer. Oh, okay, so I do have that. Cool. And then it is an I and array. P component arrays. Next component type. Strange. Okay. The next type. That actually makes a lot of sense. Let's see, and then template type name, shared pointer, component array. This is a shared pointer. Templates. Type name. Ow. My ear is really hurting me. Do that. And then std shared pointer of type component array of type t, and then this is get component array. Get components array. Okay, cool. And that's a little bit better. Const char type name, type ID t dot name. Wait. Oh, that's why. Okay, that makes a lot more sense. Because they'll be looking it up by type, actually getting the type. Okay. Let's talk about the system. Stop this, yeah. So set was faster. Using a list and using a set, and a set was faster. Okay, so let's understand this a little bit. A system is any functionality that iterates upon a list of entities with a certain signature of components. Every system needs a list of entities. I want some logic outside of the system in the form of a manager to maintain that list, so I use a system base class that only has an std set of entities. Choose an std set rather than an std list for a few reasons. First, each entity is unique, and a set is defined as having every element be unique, so it maps well logically. Secondly, each entity is an integer, which makes for easy comparison when inserting or removing from the set. Moving a specific entity from a list is O of n, because you have to start at the beginning and possibly go to the end, while removing from a set is O of log n, because it's a binary tree. However, inserting into a list is only O of 1, while inserting into a set is O log n as well. So I feel like there might be a better way of doing this. Yeah, because removing specific entities is a bit of a problem. Alright. Not without having something with an obnoxiously large memory overhead. Because we could speed it up if we didn't care about memory. There are ways of doing that, but I think this should be fine. Because unless you had an array, and you just put the entity in. Yeah, I think I'll do a set. Fourth, I tested using a list and a set was faster. Okay, So system public, and I also feel like I want to do a lot of other things that aren't public. I might want to move a few things around, but I think it should be fine. Set. Nope. I need to add set. Hash include set. No. Where are you at? Okay, that's fine, I guess. Set entity. Bruh. Yeah, I'll do that. So that's basically all that a class is. And then I can do that, but I mean, there's other ways of doing it, because I want to have something along the lines of this, where we have something a little bit different, right? We would have like a system. Right in here, we'll have, you know, the public, you know, run. Right, and in here, we'll do for auto k in entities, right? Auto const entity entities. We would have private, and then this is a void. Right, and then here we have the do this stuff. Right, and then here we'll have thing. Right, we'd have something like this. So this is pre-defined in parent, right? And then here, you know, this is defined per instance or per subclass, right? That way it'd be a lot easier to run things, and these might be static or something, I don't know. Let's see if he makes them static. Right, so let's say signature physics system, and the physics system update is all in here, you know, so we can have effectively different kinds of things, and it'd be a lot like an event kind of system, right? So for the rigid body, we'd have all these do its stuff. So that I don't have to type the 4, so I can focus on the actual math part later, right? And none of you could see any of that because I'm great at this. Okay. Let's get out of the scene engine. And I'll probably do a coordinator. So let's do system manager. System manager. Now let's do public. Template type name, shared pointer, T, register system. This is a lot. I haven't even gotten anywhere close to where any of the other stuff that I'm gonna have to do is either. This is a standard shared pointer. Shared pointer of type T. And this is register system. System. Right. Yes. And then it's a little strange. Why would you want to do that? I guess that's okay. Set signature. I want to have all the defines in the and I want to have all these things be signature. I want to have all these things be in the library rather than just free floating in freaking C++ code anyway, because I would just want these to be definitions in the header. So I want a void entity destroyed, entity E. I can do that with S, signature S, and E. Into signature changed. Oh yeah, because that's a thing. Void entity signature changed. And yes, empty signature. And you do need to update the system to facilitate the new signature of any entity, because even though the signature may change for the entity, it may not affect whether or not it is going to be pulled from the system. You know, for instance, you know, you have, say you have a physics system and a render system, you know, you remove all the components necessary for physics, but you would still maintain position. So both the physics system would have to update the signature, and the render would also have to update the signature. And both of them would have to update, but only the physics, you know, system would be pulling the entity, because the render system would still have to render. So you would need to do that. So private alt unordered map, const char signature d unordered map const char pointer and signature, and this is going to be p signatures, and then we'd have systems unordered map const char and std shared pointer system p systems. Okay. Okay. And another hash pragma region nator hash pragma and region control save. So we have to have the coordinator class coordinator. The public field, this is the void init, void create entity, create entity, yeah, this is a void destroy entity, I'm like clapping all over the place. This is hilarious to me. Template type name, void register components. Let's type name t, and this is register component, and this is a void register components. That should be nothing. Add component. Oh wait, is this templated? It is templated, okay. Templates, type name, t. This should also be void. Add component to entity e t c. Yeah. Okay, I'm doing this wrong. So the reason why I'm having it like this is because it makes it a little bit more clear as what's going on, right? Because this has the type of entity. Ergo, it is E. It doesn't need to be anything more specialized than that. Type name will move components. Templates. Type name T. Right. I mean, I guess I could do things a little bit differently, but move components from entity save, and then this one is template type name, get component, templates type name. Wait, this is get component, so it is a T. Oh, T. Get components from to T E. Component type. Get component type. Templates type name T. Components type. Get components type. And I'm just going to do that. I'm just going to copy that and then paste it. Signature S. I'm just going to copy all of these. I'll change to my naming convention. Be good. I do believe, yeah, I have those capitalized. Camel casing, stuff along those lines. Okay, cool. I am keeping everything all Gucci. Cool. Everything's all good. Understand. I tried to do it that way multiple times each time. Came upon recursive header issues. Okay, so I'm probably gonna be yeah, I'm probably gonna be changing things a little bit more. Okay, so everything should be good. So that's the end of that. Which means I need to actually implement everything. And how much do I actually want to type out myself? Right. That's the real question. Game engine scene. Okay. Let's do. Let's do pragma region entity pragma and region. All right, so let's do this, right? Alright, and then this, and that, and then that, and then that, and then that. Cool. So a lot of these things I just copied a lot of those signatures over at the end there because a lot of it was just kind of self-explanatory. So I have the alright, so let's go over the I mean, do I really want 65,500 and whatever? It's only 2 bytes. It's only 64K. So I'm fine with that, honestly. It's not too terribly crazy. It's 64 kilobytes. I mean, yeah, because I'm not even in the megabyte for the signatures. So I think that's more than okay, and the components don't need to be that big. It is a little bit overkill, but I think it's fine. And there are going to be a lot of other things that I am going to be doing to make this a little bit more robust, I feel like. Because I feel like while making the game, it'll be a lot more, I don't know, there's just things about it that I want to make sure are fine, but Okay. Energy manager. So I guess I could just do that for a lot of these, I feel like. Right. You know, just let's see, what is it? Copy. Yeah, I could do that, and then create entity. Yeah, that's easy. So here, let's do assert p living entity, or living entity count. Then max ints, and this is too many entities. Are live. So I just assert that. And is it 2 S's? It's probably 2 S's. Not there, there. Include CSERT. No. Let's cut that from there and then put that in here. I like having all of my includes in my headers. It just makes things a lot nicer for me, I feel like. Okay. Then entity ID equals m available entities dot front. Entity ID is equal to available entities dot front tab and available entities dot pop. Dot pop. Empty count plus plus return ID. Then here I want to do another assert. Let's just close these guys as we're done with them. So assert what to have the entity is less than max ints and entity out of bounds. Helps if I actually have E. E outside of bounds, and then here what we want to do is emp signatures dot reset Invalidate the destroyed entity's signature. Put the destroyed ID at the back of the queue. And then minus those, okay. Signatures at e.reset. And then entities dot push e, and then living entity count minus. Might actually want to do this at the front. Basically, the reason why I want to do it at the front instead of the back is because each of, like, just the way that C++ works. Like, well, yes, everything's on a different line. There is a potential that if you do ++ at the end, you would. Wait, no, but the beforehand is the one that does it. So it shouldn't matter. I don't know why he's doing it at the front. I'm just gonna do it at the end until something, I don't know, happens. Because I don't like it at the front. It makes it a little bit difficult to see what's going on. Yeah, I don't like it. ++ entity. I don't like that. For a fact that ++ at the end, minus at the end works. Assert set signature. Assert entity max entities. Entity out of range. Assert E less than sense and T out of range. Save, and then this is M signature entity equals signature. Okay. Signatures at E equals signature equals S. Alright, done with that one. Get signature, assert, and then return. Okay. Assert E less than X and T out of range. This one, yeah, okay. And then this is just return signatures at E. Okay, that's cool. Pragma region, and this is components. Pragma and region. let's just condense that. And then, okay, so that works. Component array. Let's skip through all that. I don't need that. I can do insert data. Virtual. None of those are that. So I could do that. And then this is the component array, so copy the component array. Type name T. What's going on here? Just do quick. Okay. And then do copy, paste, copy, paste. Oh, actually, just gonna do it the other way. Copy signature data. Copy signature. Do that. Okay. So insert data is assert. Find empty holes. Okay. So assert ATI app. And then it is dot find. And then this is the find E. So if you ATI map dot and add entity, or I should say components already added to an entity. And then m's equal to size. So it's t new index. T new index to size. Oh boy. P size. P size. ETI at entity equals new index. IDE at new index equals entity. Right. Map at E index NID. Let's call this NID. Nidhogg. And then ITE P map at NID to E. And then component array. Component array at index NID equal to components. Oh, you jerk. Components. P size plus. Cool. Now remove data. There's a lot going on here. Oh, okay. I have quite a bit to go through. Oh. Do I still have a guy watching me? I still have someone watching, allegedly. Hi. Hi, viewer. Talk and chat or something. Interact. I don't know what to say to maintain people's... I'm just coding around here. There's a lot going on here, okay, so... remove data, assert... EDI, find entity. Okay, assert PTI map dot find E is equal to PETI map dot end and assert it as cannot remove component, it's not attached. Okay. Now, first, what I want to do is copy the element, copy the end element into the deleted element's place. Right. So, in order to do that, I want to do that. So index of removed entity, size t, size t, removed ID is equal to ETI map, PTI map at E. Next of last element, size t, last ID is equal to. Wait, do you need M size anymore? I don't think so. No, since I'm removing one, I can do. Now this is a time for minus minus p size, I do believe. Doing a little bit, just a little touch of Karmakian abusive notation. No, not really Karmakian abusive notation, but this is some Karmakian crap right here. M component array, index of removed entity, component array, removed ID, equals component array, last ID. Okay, so P component array at removed ID removed ID is equal to P components array and last ID. No, I'm gonna make these like that, so I don't have to shift quite as much. Update map to point to moved spot. Update map to proper pointers. Alright. So let's see if I can figure this out right. Oh, well, I don't have the sketch. Whoops. Okay. I'm actually going to also remove that. Because I'm not going to use a utils header as much as I would love to. I'm not going to do it because it's not going to be good. Because everything is just going to be in the Foxfire engine header. Which I'm not super pleased with, but I guess I could keep that around. Okay, so if I'm going to, if I were to figure this out myself, right, I would say the ETI map at the component, the ETI map okay, well let's just kind of cheat. So it is, you get the entity of the last element, and okay, entity, okay, that makes sense. Entity last E last entity is equal to the IT map at last ID. What do you put? Right. Next to map. Next to entity ITE map. And then the ETI map at last entity is equal to last ID, and then wait, no, not last ID, it's removed ID. Yeah, removed ID. Okay, yeah, because we're moving it in. Okay, and then it's P ITE map at removed. No, add a last entity. Last entity is equal. No, add a removed ID. Removed ID is equal to last entity. Correct? Yes. And then ETI erase entity, ITE erase last ID. Erase the last elements. And here it is, ETI. ETMM dot erase. And yeah. Oh, and then we erase the entity. We erase E. Yes. And then PIT dot erase. And this is removed. Oh no, it's the last index, last ID. Okay. Yeah, that makes sense. That makes sense to me. Okay. I'm gonna say this is gonna be an assert. This is going to be E. I don't know why this is capital. I can just do E lowercase. Put an array. Yeah. Get data. Assert E is less than. Makes sense. And cannot get. Oh, it's not that. Almost. It is actually PTI map. PTI map. Dot find E is not equal to PTI map dot and cannot get data from non-existent data. Right. I'm retrieving non-negative from. Or I should just say retrieving non-existent components. Might as well do that as well. Get data, so then we'd want to return. Oh, what is it? Yeah, component array. Oh, yeah. Component array at PTI map at E. Done there. That's good. That's nice and simple. Last one. Community destroyed. Yeah, this one doesn't matter. Okay, so I'm going to do this a little bit. If eti.find, PETI map dot find E does not equal PETI map dot end. Well, if it does equal, then return. Otherwise, to remove data. E. See, I like this. And this works really well. I love stuff like this. Cool. Entity, done. No, components, done. Okay. Hash, pragma, pragma, region, systems, hash, pragma, and region. Yeah, well, that is the component array stuff. Oh, this is the component manager stuff. Array component manager. Yeah, all that is the component array stuff. So, done with that. Insert, remove, get, destroyed. Insert, remove, get, destroyed. Actually, create definition. Create definition. Create definition. Create definition. And go find out what's going on here. Yeah, I don't know what happened to wipe that audio here. It's a little strange. Now we're on the... Nope, instance of function template. Move component. Oh. And T. There we go. Kind of scuffed it up a little bit, but it's fine. Definitely getting. Why are you saying return? Okay. Register component. So we need to make sure that the char type name is type ID T name. Okay. So first, helps if I go into the correct one. So const char pointer type name is equal to type ID T, type ID T dot name, and then assert. Okay. M components types find. Okay, component types component types dot find type name not equals p component types dot end, and wait, no, you do want it to be end. Attempting to register components more than once. And cannot register component type more than once. I could say component type already registered. And oh, I got this. Okay, first we do that. Then we want to component type insert type name next component type. I mean, it's just a map, right? So I could just say M component types, P component types at index type name is equal to P next type. And since that is the last time you're doing it, next type plus plus, I do believe. Yes, because the plus plus happens after this particular time slot. This should work. To do. May cause issues. I'm just gonna leave that there for now. So, create a component array pointer and add it to the component arrays map. P component arrays. That's, yep, type name. This is a little bit easier for me to read. std make shared. This is a component array of type T. That should be fine, right? Yes. This is a lot cleaner. Okay. And that should be it. Okay, get component type. Let's do that. That's char pointer. C type. C type is equal to type ID of key dot name. Assert your dominance. Component types find. P component types dot find. C type. Not full P types dot end. Component type not found. Component not registered before use. I should say component not registered. Return component types. Return component types. That's C type. Yep. Yeah. Used for creating signatures. Okay. Add component. Okay, component array T. Insert data. Alright, this should be easy. Yeah. That's easy. Probably do something a little bit different there, but you know, that's fine. A little bit of a wrapper to a wrapper. And then remove is get components array, type T, remove data E. Yeah. Get component array, get to identity. Return get components array, type T, get components E, I do believe. Should be it. Or get data. Okay. KV auto const component equals pair. Const KV in const component equals K. Well, actually, KV. Can I just do? Can we just do C entity destroyed? That's a lot better. That's way nicer. Just gonna do that. Just to make it a little bit more explicit. Even though no one's else gonna see this except for people watching the stream. Or the VODs after I post them and make them public on YouTube. entity destroyed. Okay. And then here's get component arrays. Privates. Huh. Assert type name. Assert. Not end. Const char pointer c type is equal to type ID of t dot name assert its component types p types dot find c type not equals p component types dot end and components not registered. And component is not registered. And then all they need to do is just return static pointer cast. Static pointer cast type component array. Component array of type T and to P component arrays. Array is C type. Cool. So this one is now done. Component manager is done, which means I do believe that components is done because you only have the entity manager. You know, just for brevity, I'm just gonna do that. Okay. This should be fine because I just need the system manager. Right? Yeah. Because I can do the system manager because the systems themselves are going to be a little bit different, and then the coordinator. Okay. I'm almost done with this thing. Because then all I need to do is actually maintain the stuff that's actually going to be necessary. Right? Yeah. Okay. It's fine. Okay. So. So I will have the Pragma region system manager, Pragma and region. Yep. So copy, paste. Create. Create. Okay. I have all of those. Cool. So. Okay. System manager. What is your system? Char type name assert. Okay. Okay. Const char pointer s type is equal to type ID of t dot name. And we do a little bit of an assert, and we assert that the, what is it? The systems dot find type is at end p systems dot end alright, now the system registering the systems are fine. We don't want to do, I mean, there's like a time and place for assert and try catch and things of these natures. System end and system is already registered. I'm not entirely sure if assert does things, right? Because I might just want it to just quietly fail. So I might have to mess around with assert just to see what all happens if it throws an error, or, well, you know, I have the internet, I can figure it out. Assert. Let's see. I really don't like this. What do you want? I don't want that, I want geeks for geeks. Assert into expression. The runtime to terminate in an unusual way. Please contact the application support team for more information. So it does throw logically impossible situations. For example, they can be used to check the state of a code which is expected before it starts running, or the state after it finishes running. Unlike a normal error handling, assertions are generally disabled at runtime. Therefore, it is not a good idea to write statements in assert that can cause side effects. For example, writing something like assert x equals 5 is not a good idea, as x is changed and this change won't happen when assertions are disabled. Okay. Okay. And line number are sent to the standard error, and then abort function is called. Just 0. Interesting. Okay. So what am I doing here? Okay, so that's fine. Right? No, it's not fine. Okay. To make shared type T P systems at index s type is equal to system. Return system. Yes. Set signature. I still have anyone watching? I still technically have someone watching, allegedly. Okay, let's see. Set signature. Okay, const char stuff. Const char pointer. Stipe equals type ID of T dot name. Assert P systems dot find stipe does not equal P systems dot end and system not registered. And signatures, insert. P signatures at Stipe. Equal to, what is it? Oh. S. And that's void. Okay. Let's see here. Ivan. Live. Oh, yeah, everything's been. I think. I think I actually have a solid one. Okay. What is it? Entity destroyed. And it's for auto const stables. Yep. Okay. For auto const reference of what is it? Stipe system. Right now it's comma. And I think this is in systems, yeah. AP systems. Oh, actually. I'll just do it all in one shot. Actually, it's entities.erase. Yeah. Entities erase. Actually, I actually don't like that. For sake of brevity. Could do all this all in one line, but it's fine. I don't care. Okay, that's fine. Signatures changed. Oh, this is really crazy. I don't like any of that. Stipend system. For const auto Stipe system. For const for auto const reference Stipe system in P systems. Signature auto const S is 2 P signatures Stipe. Set. It's not match system signature. Erase from set. If entity signature. Okay, and that will not allow it. Okay, so even if it's done, it's fine. Okay, so here's some cool stuff. So if sig and how am I passing in the entity signature? Oh, because the entity doesn't have a... Yeah, because the entity doesn't own the signature. The entities don't have... Because entity is not a class. I think there are ways that I could wrap a lot of stuff up into classes and stuff. So I'll think about it. I'll see how the data structures work and see if it's... Oh, no. I think it is better to separate all the data out. To have... I'll have to think about it. Yeah, okay, so you have to do that. System empties insert empties. Empties.insert. Yeah. Let's do some other stuff. The system. Entities.erase. E. Yeah. So if it's not in there, it's gonna erase nothing. And if it is in there, then it'll do stuff. So that's fine. And oh, that's good. On to the coordinator. System manager is done. System is done. Copy. Pragma. Region coordinator. Pragma and region. The coordinator's pretty big. I don't think it should be too bad. So I should be able to get to a demo at this point. I think next stream I should work towards getting the actually drawing something. Yeah, because Yeah, I don't think I have much of anything here. Because a lot of the things don't have like the SDL or anything like that. It's not showing like any of the SDL stuff. Because they're probably using SDL instead of OpenGL. Yeah. What's going on here? Okay. Okay. Yeah, physics system update. Yeah, okay. Okay, so I guess the coordinator's just gonna be the last a little bit. Oh, God, my back. Okay, here we go. Back in here, coordinator. Now I have a better mouse. Let's just do some of these things going on, you know. Okay. And now it is time to do these things. Init component manager, make unique component manager, make unique. Okay. So make component manager equal D. Right, yeah. Okay. And P. Entity manager. D. Make unique. Entity manager. And just for the sake of my own sanity, I'm going to leave that there. That's entity component system. It is an entity component system. Unique system manager. I'm just clapping all over the place, aren't I? Oh. That's fine. Return entity manager. Create entity. The entity manager, create entity. Okay, destroy entity. Entity. P entity manager. Destroy entity. These are kind of wrappers, but it's fine. Okay with that. Okay, register components. Oh, but I also have to do component manager and system manager destroyed. Destroyed. Yeah. Entity destroyed. E, and then P. System manager. Entity destroyed. E. Okay, there we go. Now that's done. Oh, a lot of programming in your own projects is just finding the right tutorials and effectively writing your own tutorial for your project. It's all just learning. And if you like to learn, then it's a lot of fun too. So add components. Component manager, add component T, empty components. Oh, register components. Component manager. Register components. Okay. And the scene is going to have a coordinator, which means I have to types, engine, scene, virtual. Protected. I feel like it should be the scene, because you can have an entity that's spawned. You can have a component like an entity spawner, that spawner will have an entity spawner. That component will have an entity spawner system. That's possible. Okay. So there are ways around, because you'd have to create a spawning system. You could also have a scene system, because I'm planning on like extending a lot of this stuff to, right? Yeah, and the crazy thing is that you can have, like, the scene systems will be much simpler, because there's only going to be, in essence, like the number of scenes that are going to be active are going to be much lower than the number of entities that are going to be active. So a lot of the heartache is going to be lifted. Also, cache misses, even at large quantities, is not going to be that bad. I don't think. I hope not. I'll have to do some benchmarking with a lot of different stuff. So, yeah, I don't know. We'll see. So, add component. Entity. Manager. P manager. P component manager. Add components, and that is T E components. And then let's take a look here. We want to, yeah, when we add the component, we need to add the signature to the entity. We also need to set the signature to the component. What? Okay. Okay. And then, yeah, you want to flip the bit for true, and then set signature, entity signature. And then I'm gonna update the signatures. And okay. So yeah, auto sig is equal to p entity manager. Set signature. We know we want to get signature. Get signature of the entity. Okay. Of E. And then sig dot set. This is a big part. Manager dots. What is it? Get component type. Get component type of, what is it, T? And then true. set that to true, and then the P entity manager. Set signature E sig. Yeah, and then the systems manager. Systems manager. And then entity signature changed. E sig. Yep. Remove component. Let's take a look at remove components. So yeah, okay, so first of all, we want to entity manager, remove, no, you want it's manager, remove components, type T, E, correct? Yes. And then you'd have to flip it. Okay, yeah, so do literally all the same crap as before. Auto sig is equal to entity manager get signature me sig dot set, and then it is p components manager dot get a component type T dot false, and then I think the entity P entity manager sets set signature E signature, and then P system manager entity signature changed E. Sick. Okay. Return P components manager gets components T of T, and then component type is return P component manager get component type T. Return. Oh, actually, I don't know if that's going to be. Return system manager register system. Return system manager register system. T. Alright, yeah, that should be it. And then set signature. System manager, set signature, yes. Okay, so that should be good with the coordinator. That's it for that. So that is how that works. Now, there are a few reasons why I'm not liking this empty component system as is. And that's mainly because I don't have any way of spawning specific I don't have any specific way of setting things, right? Alright. So let's okay. So there are a few things that I could do. So for instance, I could do, I'm not really pleased with a lot of the kinds of, like the way that this empty component system is currently set up, I'm not super pleased with. but I think I'll have to save that for next stream. So yeah, let's do things a little bit. Let's just try and make a scene, right? So that's a thing. Yeah, so I can pretty much remove all this, right? So game run. Tester game is a game. And that's going to have a type thing. It's going to have its own engine, and it's going to push a new scene, scene 1, onto the stack. Okay. So now the scene is going to have a reference to a coordinator. And it'll have to right, and the coordinator, so the scene is going to have a coordinator. I can close engine. I can pretty much close game as well. I'm only going to be looking at scene. So scene is going to at least need a coordinator. Coordinator. Right? It's going to have a coordinator. In the right. So when you make a scene, right, you will have, I'm gonna have to do a lot of refactoring, which I feel is great. It's amazing, but it will be fine. So the scene will have to have coordinator dot init. Right. So the coordinator will be initialized. Oh wait, I also need to make a system. System manager. Pragma. Region. Systems. And then Pragma and a region. Right. Because what I'm gonna do is say class print extends public system. Okay. And then this one will be print. How do I do that? Yeah. Print system. Right. Because I want to inherit anything that's in the system constructor, which I think currently is empty. Alright, so the print system, let's take a look at this. Yeah, the external. Okay. Huh. Hmm. Because the coordinator is going to be owned. What kind of scope is the coordinator going to have? Because I feel like it depends on because the scene is going to have the coordinator. And we're going to be using the coordinator okay. Let's move that real quick. Right. Let's go back into here. Let's go back into the system. Because this is where things start getting a bit crazy, right? Systems. So I feel like it's gonna need to have is it static? No, it's not static. But the coordinator has a list of the physics system has update, which means that all of okay. Yeah. So that is a type. And what happens when you register the system? You go into the system manager and register the system there. So what happens when returns would be used externally? And that is a shared pointer to the object. at register system is when the object is created. Which means what you want to do is pass in a reference to the coordinator. So register system coordinator. Then here we want Tor. Okay. Okay. Declaration is incompatible with function template. Maybe a pointer? Okay. Let's see here. Third function C++. Declare compatible. This is a little strange. Not being instantiated. Okay, that's not what I wanted. Incompatible function definition. First case, you place the objects that are local pointer will get the address of the past object or manually pass the pointer. This is a little bit. Function template. Operation is incompatible with function templates. Definition. Okay. Can yeah, I can't even pass in the register system. Coordinator. It's the same. Why no work? What is going on here? File. Project Flexifier properties. Yeah? I'm using C++20. Now signature is not allowed. I think I have to do a lot of like externs or something. Oh, what was that? Okay. Because I want... I mean, it would be nice if the systems... Like, I wouldn't necessarily want to have something along the lines of, say... Right? Like, why can't I pass that in? Because I should be able to change the signature just fine. Is it because coordinator isn't declared yet? But that shouldn't matter. And what do you mean by signature is undeclared identifier? Wait, where's signature? Where's signature? Signature is here. Let's build again, see what kind of errors come up. Because I probably have to do a bunch of externs. Line 102. In CPP 102. Oh, 9. Am I doing syntax wrong with the assert find type name and yeah, all that's the same. Into 105. Okay. Build. Helps if I have the right stuff. I mean, it's still gonna fail, but P systems identifier 153. Let's go to 1. And solution. Too successful. Okay. So I want to have the system manager register systems. I want register system, system manager, register system, coordinator, reference, coordinator, and then in here have coordinator. Okay, that works. Make shared. Okay, C++, GD, make shared. Ugh, God, I can't read that. I think it was saying that it calls the constructor of it. Make shared song. Okay, so it does call the constructor. Right now. I'm going to do that so that in here, system, Okay, cool. And then this is going to be virtual. I mean, yeah. Let's take a look at this. C++ parent class con class constructor. Oh, I'm a bloody idiot. Yeah, I can just do that. Of course. God, I'm stupid sometimes. You know, for someone who's literally a genius, I can be quite the dumbass. Okay. Alright, I can put a manager. I don't need that. I don't need... Yeah, system manager. That's fine. The coordinator... register system in here. It'll also have to be this. Pass in register system. This. Because register system is going to go in there, and that should be fine. That should be good, right? Okay, systems. Okay, so we'll do a class print system public, and then this is going to be coordinator. Okay, hopefully this will work. Yeah, because I want to do. Oh, and I also need the system public will also be like update and all that stuff, because the systems are gonna have to have, and like there'll be different like there's gonna be different things, right? For instance, you'd have like an on update and a bunch of other things like that, right? So you can do like an on init, because they're all gonna have to be run differently. And a lot of these things are gonna be function pointers, because it's gonna be kind of like an event-based system where you can loop through. Well, yeah, because you'd be passing events down through the scenes, right? Things like on update, right? Like the update event will go through all of them. So there's also going to have to be an event thing. Oh god. It's fine, it's fine, it's fine. Pragma region. Events. Pragma region. Right. Because that's going to be a to-do thing. Right. It's the engine, the scene, the coordinator. The scene has a coordinator, and the scene will create a coordinator, and in the system, the print system will be. How do you register all that stuff? Okay, how do I use this? How do I use this thing that I just wrote? Because I don't quite understand all of it. Because the physics system update will need to have, right, because you're I mean, it's like a. So like what you're effectively doing is attaching an event. And what I would like to do, say, is have just one thing. Right. is I want this system to have, in essence, because I can have like the scenes have a let's do like the scenes will have a, I mean this will be an update. This would be like a double delta T, right? So void run is going to be a thing. Like it's going to have to, and the system is going to have its own thing, right? I would like to have that, and I would also have a virtual void on init. Right. And right, because I also don't necessarily want to have to do all these things. Because what I want to do is have, let's get rid of that one. Game update. Yeah, game run. Well, I mean, game run will be doing things, right? As the game runs, and this will be an update, but I can do like an on init here, and that's fine. It's the on init. Right. I'll do. Because I can do something like. C++. C++, yeah, function pointer, because I want to right. Because that is a doobly jam. But can I do so like Can I declare initializing a function pointer directly? C++ initializing pointer with function directly. No, it's strategy pointer. Initialize it to a particular function. Better to assign it that function when you actually need it, rather than just initializing it to null. Lets you test whether strategy pointer has been used by just if strategy pointer. Lastly, doing it this way allows you the option of having a node be an abstract base class which does not in fact possess any member functions of the right signature. No node strategy pointer. Okay. Initializing function pointer defined function. Declare the function first and then initialize the pointer with its address. Should never be done. Might want to use a captureless lambda expression instead. Void. Okay. So, what I can do is say protected coordinator. The scene has a protected coordinator. Okay. Scene also has update and on init. These are basically these kinds of things. Okay. Which means that the system class is also going to have an void on inits, and then a void. All of these are going to be virtual. Update double dt. Alright. And then I will also have protected. Yeah, these are. Oh wait, no. These. Yeah, these are not virtual. You don't need to override them. These will be set, which is fine. So protected will be void pointers. One will be on nets, and then avoid P on updates. Double DT. Okay, so these should be good. Yeah, okay. And in here, in systems, we have the system. Let's copy. See? There we go. So we got those two. And then what it'll be is, here's the crazy part, right? Essentially, I'm going to encapsulate the whole looping through everything. Right? And it may be that these are actually, instead of on init, on update, the pointers themselves are actually going to be an entity E. And an entity E double DT. Okay. Here's why. Right? Here's why. Here's the crazy part, right? Because what you end up having is 4 auto const reference entity E in entities. What you want to do is you just pass in, right? So P on init, just pass in E. That's it. That's all you gotta do. And same thing with this. Just do for auto E for auto const reference E in entities. Alright, just do B on update. You pass in E and you pass in DT. That makes things super nice, right? And I'll show you why. I'll show you why, right? Because now what we can do is right, I have these here, right? Right. Alright, I collapse these. This is really, really cool, right? Because now what we can do is protected. Well, yeah, no. Because what I can do here is public. And then I can do print system. Yeah, no, this is for and then this is this is so cool because now I can do lambdas, right? So what I can do is say, hey, P on init. How about I make you yeah, it says captureless, which means that this is going to be P on it, T, E, right? So I just have this. I can just write the function in here. It's so brilliant. It's so cool. Which means when I get the on init, that for every single entity, right? For every entity, what am I going to do? I'm going to say the transform rigid body. Yeah, I do coordinator get component rigid body entity. Alright. I need to have for one, yeah, so the system itself, the print system is going to say for every entity, right, you get e dot wait, no, auto text is equal to coordinator dots get components enclosing function local variable cannot be referenced in a lambda body unless it is in the capture list. Interesting. So I need to pass the coordinator in as well. Yeah. Which means I also need to do that. That's a little bit messy, but I'm gonna do it anyway. And I'm also going to pass this by, well, I mean, it doesn't matter. Those are things. It's a little messy. I might have a system hold a pointer to a coordinator or something. Maybe? Okay. Get component. Type name component. Well, actually, I need to also have a. I also need to have the also. Components. I do the dumb and put the component in here? Yeah, I did. Yeah, see text. Coordinator, get component, see text. Okay. Yeah, then I can do printf. Let's do string text. Right, so I can do that. Entities, text. And I can do that, right? I'm just gonna do it like that, right? That's fine. So this way, I mean, I'm not super pleased about that. Just saying. It might be better to have a reference to the coordinator. And have that be a thing that the system has. I'm gonna make the coordinator a systems reference, a systems member variable. And I can make that like constant and stuff like that, so I'll be fine. I have a bunch of stuff in here. Update, okay. Yeah, because it's actually on and on update on and yeah, and this is actually avoid the system. Do I need a think I'm gonna have to do that now, actually. That's fine. I'm actually just going to do this and this. Right. The reason being is yeah, I'll do that. System coordinate. Coordinator. Hmm? Okay, well that's fine. Yeah, coordinator. This coordinator equals to that, and that's fine. That makes things so much nicer. Because then I don't need to have this. Because then we do this might be right. Okay. So right? Yeah. It would be nice. Yeah, because I don't have the owning things, right? So this is going to have to be coordinator. Yeah, and then I need to go here. And here as well. And then in this corner, I'm not super pleased with this, but I feel like it's fine. Like, it's not great that it's a lambda. Like, the fact that it's a lambda makes things a little bit more difficult. But I think it's fine. There's enough jank already. I feel like this whole system is super janky. But, like, I think it'll be fine. Let's see here. Scene run. Don't think I need these. Right, yeah, because I have all this stuff all set up. Because the on, yes, print system, system on update, system on init, system, print system, do all that. Cool. Which means that in the scene constructor, this also makes things really cool because now you can just add in your own systems and add in your own components and it still just works. Which is something that I was very scared of previously. So modding and things like that should be super easy with like any of the, well, I mean modding might be a little bit more difficult, but I'll have to come up with a way to have mod loaders with any games that I want mods for, so, and like user content. Oh hey, how's it going? Blessif. Tell me what your least favorite programming language is and why is it Java? So the coordinator init, I need to initialize the coordinator. I also need to register components, coordinator register components, and this would be C text, and then coordinator dot register system, and this will be print. Glad to hear that you're doing alright. Why is that not working? Physics system. Yeah, but why is it not letting me? Print is undefined. Not really, but I'm not one of those kinds of people. Let's see. So why is that? Oh, that's why it's not defined. Because of course it's not defined. Ah, because it's not in the header. Okay, that's fine. Because I need to class system. Pragma. I mean, I'm more of a spiritual person, personally. I don't know, I feel like I'm too grounded in what is here and around me, and I don't know, I haven't seen much evidence. I'm too scientifically minded. Pragma, region, systems, definitions. Pragma and region. Let's see here. And I would say, oh, what? Cannot be initialized with the value of coordinator pointer. That's a complicated question. I feel like it would be nice if there is some type of afterlife. You know, like it'd be cool. Cannot be initialized. Not const qualified, cannot be initialized with a value type of a reference of type coordinator, cannot be initialized with a value of type coordinator. Pointer. Yeah, expected a member name. No, doesn't do that. And that. So a pointer to member type. I mean, okay. I'm gonna put it like this. I would like to refrain from talking about religion or politics in my stream. So I would prefer it if you would refrain from having lengthy conversations. Asking a couple questions about, you know, spirituality or whatever religion or side of the political spectrum that, you know, I lie on is fine, but going much further than that is kind of pushing it. Just saying. I'm a programming streamer, not a TED Talk streamer, not a discussions streamer. So I don't. It's a bit off topic. Okay, so a reference of type coordinator cannot be initialized with type value. So I have to have. Oh, what happens if I do this? Anything that I can do? Initialize value reference and non must be no, that doesn't work. So I guess needs to be an actual pointer instead of a reference? Probably. So this needs to be a pointer. This needs to be a pointer. Yeah, that fixes all that. Which means that in the actual system itself, it'll need to be Alright, so in the system, yeah, you know, I'm gonna do this. I have warned you that I am going to that I don't want extensive. Oh, I can't. There we go. Yeah, I'm gonna time you out. I appreciate you being in my stream and all that, but I'm okay with not having extensive paragraphs of biblical stuff in my chat. I'd prefer it if you didn't. So enjoy the time out. I'm gonna go back to working on what I'm doing. I asked you kindly not to have extensive religious or political talk, and you went and wrote a whole essay, so enjoy the time out. So, print system. Oh wait, no, class print system. How am I gonna have to do this? Public. Come on, computer. Alright, so public. Print. Okay. Yeah. Your reference. Tour. And then system. Okay, that was weird. Wait. This? I feel like that. And then in here. Oh wait, no. Print. Prints. Tour. Don't I have to do it in the header? That's a little strange, but I'll deal with it, I guess. I'm not super pleased with that, but I guess it is what it is. And I think it will do that. It should, at least. Okay, so protected. Print coordinator. Wait, no, wait. Oh yeah. Right? No. It is in here. I do the whole on. Yeah. I'm doing the system, so it's p on init is equal to lambda. And what is the definition here? Enter. Yes. Yes, okay. Okay, here we go. So, on init, print on init. What was I doing again? There we go. I was making it so that actually worked. That's what I was doing. So here it is printf s and n, and then that will be the text, and I'll define text here. TD string text is equal to. How did I do this before? Right, because it's auto. Oh yeah, it was an auto. Auto is equal to tor. It is in the. Let me make this C. Okay, that's fun. I'm gonna make coordinator. I don't like any of that. I'll have to think of it sometime later, I guess. Get component. See text. What happens if I just minimize and then redo? Okay, well, it's still bloody there. God damn it. E. Okay, cool. So that works. That's fine. It's not yelling at me anymore. Okay. That's doing that. then we get the system. I don't think you really need to have the app because the physics system updates. Okay. So I'm still not. Alright, but that's physics system. Yeah. Oh, princess is equal to a coordinator body. I don't like that. And we'll be refactoring all this stuff later. Because do I want to have the coordinator do it all in the scene? Well, I mean, because it's kind of nice that you can just register all the components. You can register only the components that you need for that scene. So you can do things like register, you know, vector 2D or all the stuff like that. So I think I'll keep it for now. And then I'll have the that's all the entities. Okay, so that's for generating all of those. Yeah, I can have like a loop of like 5 of them or whatever, or I could just hand code them. So, 1 equals create entity. Enter dot create entity. Dot add components. It is C text E1 C text C text, and then right, what's the yeah, okay, text equal to identifier text is undefined. Now, we'll just do this then, I guess. Just build everything and see if it actually works. Where 125? What? Syntax. Error. Missing. What? W3 schools. Let's go. Yeah, I'm doing that properly. So... Oh my god. No. Stop. What are you doing? Jesus Christ. Foxfire H125. Why don't you like me? What is going on? God. How does core need to be? But I can't. What is going on? Why can't I do this? Okay, so I need to... Okay. Retain objects of the other types, since otherwise you need infinite space for the object. Since foo has a bar. Okay, say foo exists without defining it. Okay, now we're gonna build fully. God, my computer is struggling. This is the undefined type coordinator text must be initialized. What? So you need to use 4 declarations so that 2 classes know each other's existence. Don't include each other, instead they just know of the existence of the other class via 4 definition. And in CPP for the 2 classes, you can include the other header to get full information about the class. These 4 declarations allow you to break the reference cycle of foo needs bar needs foo needs bar. Use of undefined type. C++ use of undefined type. Actually, you are using core before it is actually defined. You can fix this easily in your example by moving the constructor implementation out of the class definition. Does coordinator need anything? No, it doesn't. Okay. Which means that I can cut all of that and move this above system. Which means that instead of class coordinator, instead of this here, I want to forward declare system. This system is the last one. So class system. And we'll forward declare system for class so that it knows what it's doing. And then I'll build it. Undeclared identifier system manager. And I also need to do system manager. System. Okay, system manager. Build solution. Jesus Christ, dude. What? Where is that? I'm just gonna use CO. Why? Why? Yeah. Okay. Static cast conversion from system. H163. Oh. Do that. Mine system. Okay. Oh boy. Unresolved external symbol. Yeah, I'm just gonna have to be done. I'm gonna be done for now.